Right now, scientists are bouncing laser beams off mirrors that Apollo astronauts placed on the moon's surface over 50 years ago, and you can track these experiments in real time. But if you mention this to certain people, they'll tell you it's all part of an elaborate hoax. Despite having compelling evidence like still-working retroreflectors and high-resolution orbiter photos from 4 independent nations that would be impossible to fake, moon landing conspiracy theories have exploded in the social media age. If not whether we landed on the moon, why do more people doubt it today than when it actually happened? The digital age conspiracy explosion. The answer lies in how digital technology has transformed the spread of misinformation. A 2021 nationally representative survey found about 12% of Americans thought the landings were staged, compared to just 5% in the 1970s. Younger adults show higher skepticism in multiple polls, according to the Carsey school data. We live in an age where anyone can access thousands of hours of mission footage, examine detailed technical specifications, and review decades of peer-reviewed research about lunar samples. Yet skepticism has doubled. This creates one of the most puzzling contradictions of our information age. Never before have humans had such immediate access to documentation, analysis, and verification of historical events. The entire Apollo program archive sits online, searchable, and free. High-resolution photographs from multiple space agencies show the landing sites with unprecedented clarity. International laboratories continue studying moon rocks using techniques that didn't exist in 1969. Despite this avalanche of confirmatory evidence, conspiracy theories have found more fertile ground than ever before. Algorithms reward emotional, sensational content like moon landing hoax videos, driving millions of views and rabbit hole recommendations. YouTube has become particularly problematic in amplifying these theories. Channels dedicated to moon landing denial have accumulated millions of subscribers and hundreds of millions of views. Some of these content creators have turned conspiracy promotion into full-time careers, earning substantial revenue through advertising, merchandise, and paid subscriptions. Their videos often feature professional production values, authoritative-sounding narration, and selective use of real NASA footage to build credibility before introducing fabricated claims. The platform's recommendation system creates what researchers call rabbit holes. A user might start by watching legitimate space content, but gradually get guided toward increasingly conspiratorial material. Each video pushes the boundaries slightly further, normalizing doubt about established facts. Studies tracking user behavior show that people who watch one conspiracy video are exponentially more likely to be recommended similar content, creating closed loops of misinformation. Facebook groups dedicated to moon landing denial have grown to include hundreds of thousands of members worldwide. These communities provide social reinforcement for beliefs that would face immediate challenge in mainstream discussions. Members share doctored images, misinterpreted data, and debunk claims as if they were breaking news. The group dynamics create pressure to accept increasingly elaborate theories to maintain membership and social standing within these communities. The psychology driving this phenomenon runs deeper than simple misinformation. Conspiracy theories offer believers a sense of special knowledge and intellectual superiority, claiming that millions of scientists, engineers, and government officials have been fooled, while you see through the deception provides powerful psychological rewards. It transforms believers from passive consumers of information into active detectives uncovering hidden truths. Modern video editing technology has paradoxically made people more suspicious of authentic historical footage. When anyone can create convincing fake videos using smartphone apps, viewers naturally become more skeptical of all visual evidence. Conspiracy promoters exploit this uncertainty by pointing to natural artifacts in 1960s film and video as proof of manipulation. They ignore the fact that the supposed flaws they identify are actually evidence of authentic period technology and conditions. The speed at which false information spreads online vastly exceeds the pace of factual corrections. A conspiracy video can reach millions of viewers within hours of being posted. The scientific community's response, typically involving peer review and careful analysis, takes weeks or months to publish. By then, the misinformation has already shaped public opinion and moved on to new platforms. Researchers have documented that false stories spread 6 times faster than true stories on social media platforms. Financial incentives drive much of this content creation. Conspiracy theories generate significantly more revenue than educational content through higher engagement rates and more passionate audiences. Content creators quickly learn that questioning established facts brings more subscribers and advertising income than supporting them. Some prominent conspiracy promoters have built media empires worth millions of dollars by consistently attacking scientific consensus on multiple topics. The decline in trust toward traditional institutions has created additional space for conspiracy theories to flourish. Polls show decreasing confidence in government agencies, scientific institutions, and mainstream media across multiple demographics. This institutional skepticism makes alternative explanations more appealing, even when those alternatives require believing in massive coordinated deceptions involving hundreds of thousands of people across multiple countries and decades. Educational systems have struggled to keep pace with this information environment. Many schools still teach media literacy as if students primarily consume information from traditional sources like textbooks and television news. Students receive little training in evaluating the credibility of social media content, understanding algorithmic bias, or recognizing sophisticated propaganda techniques used in modern conspiracy promotion. The global nature of social media has allowed conspiracy theories to transcend national boundaries in unprecedented ways. Ideas that might have remained isolated to small local communities can now find worldwide audiences within hours. International conspiracy communities cross-pollinate their theories, creating increasingly complex narratives that incorporate elements from multiple cultures and belief systems. The most sophisticated conspiracy promoters have adapted by shifting their tactics. Rather than denying all evidence, they focus on creating enough doubt to make verification seem impossible for ordinary people. They present legitimate scientific disagreements about minor details as if they invalidate entire missions. They exploit the natural complexity of space technology to suggest that no one without advanced degrees can truly understand what happened. This strategic approach proves remarkably effective because it doesn't require people to accept obviously false claims. Instead, it simply asks them to remain skeptical of official accounts while avoiding the hard work of actually examining evidence. But while conspiracy theories multiply online, something remarkable continues happening in the physical world that no amount of digital manipulation can fake. The retroreflector proof that never stops working. Our secret weapon against these theories involves lasers that still ping the moon today. At this very moment, researchers at observatories around the world are firing laser pulses at the moon and measuring the precise time it takes for that light to return to Earth. They can do this because Apollo astronauts left behind corner cube retroreflectors during their lunar missions, and these devices have been functioning continuously for over 5 decades. The McDonald Observatory in Texas conducts these measurements regularly, along with facilities in France, Germany, Italy, and several other countries. Each laser pulse travels roughly 480,000 miles round trip, and scientists can measure this journey to within millimeter precision. The retroreflectors work on a simple but elegant principle. Unlike a regular mirror that reflects light at various angles depending on its orientation, corner cube retroreflectors always send light directly back to its source. These devices consist of 3 mirrors arranged at precise 90-degree angles to each other, creating a corner that bounces incoming light straight back along the same path it arrived. This design means the retroreflectors function regardless of the moon's orientation or the angle of incoming laser light. The precision achieved through lunar laser ranging experiments defies comprehension. Scientists routinely measure the distance between Earth and Moon to within 2 millimeters across a gap of 238,855 miles on average. To put this accuracy in perspective, It would be equivalent to measuring the distance between New York and Los Angeles to within the thickness of a human hair. This incredible precision requires physical objects on the lunar surface, not clever fakery or remote technology. Apollo missions placed retroreflectors at 4 different locations on the moon. The Apollo 11 crew deployed a 2-foot square array containing 100 corner cubes at the Sea of Tranquility. Apollo 14 astronauts positioned a similar device at Fermaro, while Apollo 15 installed a larger array with 300 corner cubes at Hadley-Apennine. Each placement required careful positioning and alignment by human hands working in bulky spacesuits under challenging conditions. The characteristics and locations of the Apollo retroreflectors provide clear evidence of human installation. The Apollo arrays were positioned at optimal angles and orientations that required real-time human judgment about local terrain and lighting conditions. Astronauts could assess the surrounding landscape and make minute adjustments to maximize the effectiveness of laser ranging experiments. The precision of placement demonstrates the kind of careful consideration only possible with human operators on site, making decisions based on immediate visual assessment. Additionally, the Apollo retroreflectors show signs of being moved slightly from their initial positions over the years, something that would be impossible if they were merely dropped from orbit or positioned by robotic arms. Ground controllers had no way to remotely adjust retroreflector positioning after deployment, yet slight movements detected through laser ranging data indicate that astronauts made manual corrections during their surface operations. Multiple observatories worldwide independently verify these laser ranging measurements on a daily basis. The Apache Point Observatory in New Mexico fires laser pulses at all 4 Apollo retroreflector locations as part of ongoing research programs. French researchers at the Côte d'Azur Observatory have been conducting similar experiments since 1984. German scientists operate laser ranging equipment at the Wetzel Observatory, and Italian researchers maintain their own independent verification systems. Even Chinese researchers have begun their own laser ranging programs, and their results match data collected by American and European facilities. These measurements have enabled remarkable scientific discoveries that extend far beyond simply proving the moon landings occurred. Researchers have determined that the moon moves away from Earth at a rate of 3.8 centimeters per year due to tidal forces gradually transferring energy from Earth's rotation to the lunar orbit. This measurement required decades of continuous data collection and wouldn't be possible without the stable reference points provided by retroreflectors. Scientists have also used retroreflector data to test Einstein's theory of general relativity with unprecedented precision. The measurements reveal tiny variations in the moon's orbit that match theoretical predictions about how massive objects warp spacetime. These experiments have confirmed that the gravitational constant remains truly constant over time, and that the moon's core is partially molten based on how gravitational forces affect its rotation. The retroreflector experiments have undergone continuous technological improvements since the 1970s. Early laser systems could barely detect the faint return signals from lunar retroreflectors, but modern equipment uses adaptive optics to compensate for atmospheric distortion and can track return signals with extraordinary sensitivity. Current systems can detect individual photons returning from the moon, allowing for measurements during daylight hours and under conditions that would have been impossible with 1970s technology. The ongoing success of these experiments demonstrates the remarkable engineering quality of equipment installed during Apollo missions. The retroreflectors have survived temperature variations ranging from minus 250 degrees Fahrenheit during lunar night to over 250 degrees Fahrenheit in direct sunlight. They have endured micrometeorite impacts, cosmic radiation, and thermal cycling for more than 50 years while maintaining their optical precision. The financial investment required to maintain these experiments over 5 decades demonstrates the scientific community's confidence in their authenticity. Observatories have spent millions of dollars upgrading laser systems, training personnel, and conducting thousands of measurement sessions. This sustained commitment would make no sense if the scientific community had any doubt about the physical reality of the retroreflectors. The retroreflector proof stands as just one element in an interconnected system of evidence supporting the reality of lunar exploration. But these laser experiments represent only part of what Apollo astronauts brought back from their journeys to another world. Moon rocks that fooled no one. Apollo missions brought back 842 pounds of lunar material from 6 different landing sites scattered across the moon's surface. This collection represents the largest cache of extraterrestrial samples ever obtained, distributed among thousands of individual specimens ranging from fine dust particles to rocks weighing several pounds. Each sample was carefully documented, photographed, and cataloged during collection, creating an unbreakable chain of evidence connecting specific rocks to exact locations where astronauts gathered them. Scientists from 60 countries have studied these lunar samples over the past 5 decades, subjecting them to every conceivable form of analysis. Researchers at institutions including Harvard, MIT, the University of Tokyo, the Max Planck Institute, and hundreds of other laboratories worldwide have published thousands of peer-reviewed papers based on lunar sample research. The international distribution of samples began immediately after each mission, with NASA sharing material with allies and even some former adversaries to ensure independent verification of authenticity. The unique characteristics of lunar rocks make them impossible to counterfeit using any known methods. These samples contain no water whatsoever, not even trace amounts bound within crystal structures. Earth rocks invariably contain water molecules incorporated during their formation, even in the most arid desert environments. The complete absence of water in lunar samples reflects formation in an environment where water never existed, a condition impossible to replicate artificially. Solar wind particles embedded within lunar rock surfaces provide another unmistakable signature of authentic lunar origin. These high-energy particles from the sun strike the moon's surface continuously, penetrating several micrometers into exposed rock faces. The pattern and depth of solar wind implantation matches exactly what scientists predicted based on theoretical models of solar radiation exposure over millions of years. Creating this effect artificially would require particle accelerators and techniques that didn't exist in the 1960s. Mineral compositions found in lunar samples reveal formation processes completely different from terrestrial rocks. Lunar basalts contain high concentrations of titanium and unusual ratios of magnesium to iron that reflect crystallization in the moon's low-gravity environment. Lunar highland rocks consist primarily of anorthosite, a mineral composition extremely rare on Earth, but predicted to be common on the moon based on models of lunar formation. These compositional differences weren't fully understood until after the samples were analyzed, making their accurate prediction and artificial creation impossible. Independent laboratories worldwide have confirmed sample authenticity using techniques unavailable during the Apollo era. Mass spectrometry analysis reveals isotope ratios that differ significantly from Earth rocks, but match meteorite samples known to originate from the moon. Electron microscopy shows distinctive crystal structures formed under conditions of extreme temperature variation and cosmic radiation exposure. X-ray diffraction patterns reveal mineral phases that exist only under the specific pressure and temperature conditions found on the lunar surface. Conspiracy theorists sometimes claim that Antarctic meteorites could have been used to fake lunar samples, but this explanation collapses under scientific scrutiny. Lunar meteorites found on Earth are extremely rare, with only about 300 specimens discovered worldwide. These meteorites total less than 50 pounds of material, nowhere near the 842 pounds returned by Apollo missions. Additionally, meteorites show clear signs of atmospheric entry and terrestrial weathering that are completely absent from Apollo samples. The quantity and variety of lunar samples rule out any possibility of deception through meteorite substitution. Apollo missions returned rocks from highland regions, mere basalts from ancient lava flows, breccias formed by impact events, and soil samples from multiple locations. This diversity reflects the geological complexity of different lunar regions and matches predictions made by planetary scientists before the missions occurred. No collection of meteorites could provide such varied and location-specific material. Scientific discoveries made using lunar samples have revolutionized understanding of solar system formation. Analysis revealed that the moon formed from debris created when a Mars-sized object collided with early Earth, a theory now widely accepted based largely on isotopic evidence from Apollo samples. The age dating of lunar rocks confirmed that intense bombardment occurred throughout the inner solar system about 3.9 billion years ago, a period now called the Late Heavy Bombardment. The chain of custody for lunar samples makes fakery logistically impossible. Every sample was witnessed during collection by multiple astronauts, filmed by television cameras, and documented in mission transcripts. Upon return to Earth, samples were processed in specially constructed laboratories under strict contamination protocols. Individual specimens were subdivided and distributed to researchers worldwide, creating thousands of separate pieces of evidence that would all need to be consistent with the same elaborate deception. International sample exchanges have created additional verification networks that extend far beyond NASA's control. Soviet scientists received lunar samples in 1976 as part of a scientific cooperation agreement. Chinese researchers have analyzed Apollo samples since the 1990s. European laboratories maintain their own collections. Distributed by NASA decades ago, any attempt to fake lunar samples would have required coordinating deception across dozens of countries and hundreds of institutions over multiple decades. The economic value of lunar samples has created strong incentives for verification of authenticity. Tiny fragments of Apollo samples have sold at auction for hundreds of thousands of dollars, making thorough authentication extremely profitable for potential buyers. Gemological laboratories, insurance companies, and auction houses have subjected samples to intensive analysis using the most advanced techniques available. No evidence of artificial creation or terrestrial origin has ever been detected despite strong financial motivations to expose fraud if it existed. But physical samples represent just one form of evidence that conspiracy theorists must explain away. The CIA, the USSR, Europe, India, and Japan have all photographed Apollo equipment from orbit. There's no global studio for that kind of coordination across decades of international space missions. High-resolution satellite images of landing sites. Modern orbital missions have captured these landing sites in unprecedented detail. The most comprehensive images come from NASA's Lunar Reconnaissance orbiter, which has been circling the moon since 2009 and capturing photographs with resolution sharp enough to show individual pieces of equipment left behind by astronauts. These images reveal hardware, tracks, and surface disturbances at all 6 Apollo landing locations, creating a visual record that matches mission documentation from the 1960s with extraordinary precision. The Lunar Reconnaissance Orbiter camera captures images with pixel sizes as small as 0.5 meters, meaning objects larger than about 18 inches across appear as distinct features in the photographs. At this resolution, the lunar module's descent stages appear as bright rectangular objects casting shadows that match the sun angles recorded during each mission. The Apollo 17 landing site shows particularly clear details, including the lunar rover parked exactly where astronauts left it after their final moonwalk, its tracks still visible leading back to the landing module. These orbital photographs reveal details that precisely match mission documentation created decades before such high-resolution lunar imaging became possible. The Apollo 14 site shows equipment scattered in patterns that correspond exactly to maps drawn by astronauts Alan Shepard and Edgar Mitchell during their surface operations. Scientific instruments appear in locations marked on hand-drawn diagrams from 1971, positioned at distances and orientations that match written reports filed immediately after the mission. International orbiter results from China, India, Japan, and Europe all match Apollo site locations. China's Chang'e 2 spacecraft photographed the Apollo 11 and Apollo 17 sites in 2010, producing images that clearly show the same equipment visible in American photographs. India's Chandrayaan One mission captured images of Apollo landing sites using its terrain mapping camera, providing verification from a nation that had no involvement in the original space race. Japanese lunar missions have similarly photographed Apollo sites, creating an international database of verification that spans multiple decades and political systems. These nations had no reason to perpetuate an American hoax. China and India compete directly with American space programs for prestige and funding. Russia maintains detailed records of American space activities from the Cold War era and would gain significant propaganda value from proving Apollo missions were faked. The fact that former rivals and current competitors consistently confirm American achievements through their own independent observations provides compelling evidence of authenticity. Visible equipment at landing sites includes descent stages from lunar modules, scientific instrument packages, and lunar rovers from later missions. The Apollo 15 site clearly shows the lunar rover positioned about 300 feet from the landing module, exactly where astronauts David Scott and James Irwin parked it after their final exploration traverse. Solar panels from scientific experiments appear as small bright rectangles oriented to catch maximum sunlight, just as mission planners intended. The patterns of astronaut footpaths visible in orbital photographs match documented exploration routes with remarkable accuracy. Apollo 17 images show a network of trails connecting the landing site to various geological features that astronauts Harrison Schmitt and Eugene Cernan visited during their 3 moonwalks. These paths follow the exact routes described in mission transcripts and shown on maps created during flight planning. The trails branch out from the landing site in directions that correspond to specific scientific objectives outlined before the mission launched. Achieving such photographic resolution from lunar orbit required overcoming significant technical challenges that demonstrate the sophistication of modern space technology. The Lunar Reconnaissance Orbiter operates in a circular orbit just 31 miles above the lunar surface, traveling at over 3,600 miles per hour, while maintaining precise pointing accuracy needed for sharp imaging. The spacecraft uses reaction wheels and thrusters to counteract orbital perturbations caused by variations in lunar gravity, keeping cameras stable enough to capture clear images of small surface features. Camera systems aboard these orbital missions use advanced electronics and imaging sensors that far exceed the capabilities of 1960s technology. The Lunar Reconnaissance Orbiter camera system weighs just 15 pounds, but produces images with clarity that would have required room-sized equipment during the Apollo era. This technological advancement means that modern orbital photographs show details that were completely unknown to the public when conspiracy theories first emerged in the 1970s. The images reveal surface disturbances and equipment arrangements that were never publicized in contemporary mission coverage. Television broadcasts from the moon showed only limited views of immediate landing areas, while orbital photographs capture the full extent of astronaut activities across much larger regions. These comprehensive views show equipment caches, experiment locations, and exploration paths that were documented in technical reports but never featured in popular media coverage of the missions. Dust patterns visible around landing sites provide additional evidence of rocket engine interactions with the lunar surface. The Apollo 12 landing site shows areas where exhaust from the lunar module's descent engine scattered surface material in patterns consistent with rocket exhaust impinging on fine lunar soil. These disturbance patterns extend outward from the landing point in directions that match theoretical predictions about how rocket exhaust would behave in the moon's vacuum environment. International space agencies now treat Apollo landing sites as protected historical landmarks worthy of preservation for future generations. The International Astronomical Union has officially recognized Apollo landing locations as cultural heritage sites, similar to how ancient ruins are protected on Earth. This designation acknowledges the historical significance of these locations and establishes guidelines for future missions to avoid disturbing the artifacts left behind by astronauts. The cumulative weight of orbital photographic evidence creates verification that extends far beyond any single space agency or national program. This convergence of evidence from competing nations and institutions would be impossible to coordinate as part of any deception scheme. But perhaps the most telling evidence comes not from what we can see today, but from what America's greatest rival chose not to say. The Soviet Union tracked every American spacecraft throughout the Apollo program and never once questioned whether the missions actually reached the moon. At the height of the Cold War, when the two superpowers competed fiercely for global prestige and influence, America's greatest rival possessed every conceivable motivation to expose a lunar landing hoax if one had existed. The political prize for proving American deception would have been enormous, yet Soviet leaders, scientists, and media consistently acknowledged the reality of Apollo achievements throughout the 1960s and 1970s. Soviet tracking capabilities during the Apollo era were sophisticated enough to monitor every aspect of American lunar missions in real time. The USSR operated a network of radio telescopes and tracking stations across their vast territory, including facilities in the Crimea, Kazakhstan, and Siberia that could detect and analyze radio signals from spacecraft anywhere in the solar system. These installations routinely monitored American space activities as part of intelligence-gathering operations, giving Soviet engineers detailed knowledge of launch trajectories, orbital mechanics, and communication protocols used during Apollo missions. The Jadrell Bank Observatory in England, operated by British scientists but accessible to Soviet researchers through academic exchanges, independently tracked Apollo spacecraft throughout their missions. Radio signals from lunar orbit and the moon surface were detected by multiple countries, creating an international network of verification that extended far beyond American control. Soviet monitoring stations would have immediately detected any inconsistencies between claimed spacecraft positions and actual radio signal sources. Soviet space officials publicly acknowledged American lunar achievements despite having every reason to question them if doubt existed. Academician Mstislav Keldysh, president of the Soviet Academy of Sciences and chief theoretical mind behind the Soviet space program, congratulated NASA on the Apollo 11 success. Sergei Korolev's successor, Vasily Mishin, who directed Soviet lunar program efforts, never questioned the authenticity of American achievements, even in private communications that have since been declassified. Technical evidence that Soviet tracking stations collected makes the possibility of successful deception virtually impossible. Radio transmissions from the lunar surface carried distinctive characteristics, including time delays that corresponded exactly to the 238,000-mile distance between Earth and Moon. These delays, amounting to 2.6 seconds round trip, were monitored by Soviet facilities and matched theoretical predictions perfectly. The Doppler shift effects on radio signals also corresponded to spacecraft moving at velocities consistent with lunar orbital mechanics. Soviet engineers possessed detailed knowledge of rocket performance capabilities and orbital dynamics that would have made detecting fake missions straightforward. The USSR had been attempting their own lunar landing program since the early 1960s and understood exactly what technical achievements were required for successful missions. Their tracking data showed American spacecraft following trajectories and exhibiting performance characteristics that matched Soviet calculations for actual lunar missions. The political climate of the late 1960s made exposure of American deception not just attractive, but virtually irresistible for Soviet leadership. The space race represented a crucial front in Cold War competition, with both nations investing enormous resources and national prestige in demonstrating technological superiority. Soviet Premier Leonid Brezhnev and his government faced domestic pressure to challenge American claims if any credible doubt existed about their authenticity. Soviet media coverage of Apollo missions reflected genuine acceptance of American achievements rather than grudging acknowledgement of successful deception. Pravda and other official publications reported on lunar landings with technical detail that suggested their correspondents understood the missions were authentic. Soviet television even broadcast some Apollo footage, indicating government confidence that the missions posed no propaganda risk through obvious signs of fraud. Communications between Soviet and American space officials during Apollo missions revealed cooperative attitudes that would have been impossible if either side suspected deception. Soviet tracking stations provided assistance to NASA during critical mission phases, sharing radar data that helped ensure astronaut safety during lunar operations. This cooperation required Soviet officials to accept the reality of American achievements and demonstrate their own technical capabilities through accurate tracking support. Soviet intelligence services, among the most capable in the world, had extensive networks of agents within American aerospace industries and government agencies. These intelligence operations focused heavily on gathering information about American space capabilities and would have detected any massive deception involving hundreds of thousands of NASA employees and contractors. The KGB's failure to uncover evidence of lunar landing fraud, despite having strong incentives and capabilities to do so, provides additional confirmation of mission authenticity. The competitive dynamic between Soviet and American space programs created natural verification mechanisms that made deception extremely difficult. Both sides monitored each other's activities intensively and would have gained enormous advantages from exposing rival fraud. The fact that this competitive scrutiny never revealed evidence of American deception strongly suggests that no such evidence existed. Soviet space program documentation that has been declassified since the end of the Cold War shows consistent acceptance of American lunar achievements. Internal memos, technical reports, and planning documents treat Apollo missions as legitimate accomplishments that Soviet programs needed to match or exceed. These private communications, never intended for public consumption, reveal genuine respect for American technical capabilities rather than suspicion about possible fraud. The timing of Soviet lunar program cancellation also supports the authenticity of American achievements. The USSR abandoned their own crewed lunar landing efforts in the early 1970s, shortly after multiple successful Apollo missions demonstrated that America had achieved the primary space race objective. This decision made strategic sense only if Soviet leaders accepted that America had actually accomplished lunar landings and that continuing expensive competitive efforts were no longer worthwhile. The Soviet Union's consistent acceptance of American lunar achievements represents perhaps the most compelling single piece of evidence supporting Apollo mission authenticity, because it came from the one source with the strongest motivation, best capabilities, and greatest opportunity to expose any deception that might have existed. But even this political evidence pales beside a more fundamental problem that conspiracy theorists rarely consider: the technology that made faking impossible. The technical barriers to creating convincing fake moon landing footage in 1969 would have required technology far more advanced than what NASA used to actually reach the lunar surface. The film and television industry of the late 1960s operated with primitive equipment compared to modern standards, relying on practical effects, miniatures, and optical compositing techniques that left obvious traces of their artificial nature. The most sophisticated science fiction productions of the era, including Stanley Kubrick's 2001, A Space Odyssey, required years of painstaking work to achieve effects that still looked noticeably artificial when examined closely. Special effects technology in 1969 consisted primarily of matte paintings, miniature models, and crude optical printing systems that combined multiple film elements. The process of creating composite shots involved photographing actors against blue or green screens, then manually combining these images with background footage using optical printers that introduced visible grain, color shifts, and resolution loss with each generation of copying. Even the most expensive Hollywood productions struggled to create convincing composite shots that didn't reveal telltale signs of artificial construction. Apollo footage contains visual elements that were impossible to create using 1960s filmmaking technology. The behavior of dust kicked up by astronauts' boots follows perfect parabolic trajectories without any air resistance, creating graceful arcs that settle immediately upon hitting the lunar surface. This dust behavior requires a perfect vacuum environment combined with 1/6 Earth gravity, conditions that no sound stage could replicate. Earth-based dust particles float and drift due to air currents, creating visible differences in particle motion that trained observers can easily detect. The construction of sound stages large enough to film convincing lunar landscapes would have exceeded the technical capabilities of any existing film studio. Apollo footage shows unbroken panoramic views extending to horizons several miles away, requiring sets with dimensions measured in thousands of feet rather than the hundreds of feet typical of the largest sound stages. The lunar surface's distinctive lighting conditions, with harsh shadows cast by unfiltered sunlight and no atmospheric scattering to create ambient illumination, would have demanded lighting systems beyond anything available to filmmakers. Creating the vacuum conditions necessary for authentic dust behavior would have required building the world's largest vacuum chamber, a facility that didn't exist in 1969 and would have cost more than the entire Apollo program budget. Even modern vacuum chambers used for spacecraft testing are tiny compared to the volumes that would have been needed to film full-scale lunar exploration sequences. The engineering challenges of maintaining vacuum conditions while operating cameras, lighting equipment, and life support systems for actors would have been insurmountable using 1960s technology. Technical challenges extended beyond visual effects to include the simulation of radio communications from lunar distances. Genuine Apollo transmissions exhibit characteristic time delays of 2.6 seconds for round-trip communication between Earth and Moon, delays that result from radio signals traveling 480,000 miles at the speed of light. Creating fake transmissions with accurate delay characteristics would have required sophisticated radio equipment and precise timing coordination that exceeded the capabilities of television production facilities. The Doppler shift effects present in Apollo communications provide another technical signature that would have been impossible to fake convincingly. As spacecraft moved toward or away from Earth during orbital maneuvers, radio frequencies shifted in ways that corresponded exactly to velocity changes predicted by orbital mechanics calculations. Simulating these frequency variations would have required real-time computation capabilities that didn't exist in 1969 and understanding of spacecraft dynamics that was available only to actual mission controllers. Modern computer graphics experts who have analyzed Apollo footage confirm that 1960s technology couldn't have produced the visual effects present in lunar surface sequences. Digital compositing techniques that make seamless visual effects possible today didn't exist until the 1990s, and even early computer graphics systems of the 1970s produced obviously artificial-looking imagery. The natural interaction of light, shadow, and surface texture visible in Apollo footage required physical presence in the actual lunar environment. The lighting consistency across different Apollo missions reveals conditions that could only exist on the lunar surface. Shadows fall in directions that correspond exactly to sun angles calculated for specific dates and times at each landing location. The absence of atmospheric scattering creates lighting conditions with stark contrasts between illuminated and shadowed areas that cannot be replicated using artificial lighting systems. Film sets inevitably show evidence of multiple light sources and atmospheric effects that are completely absent from lunar footage. Motion characteristics of astronauts working in 1/6 gravity conditions show adaptations to reduced weight that actors couldn't simulate convincingly under normal gravity conditions. The slow, bouncing gait of lunar surface exploration reflects genuine adaptation to low gravity environments and the constraints of pressurized spacesuits. Attempts to simulate these movement patterns using wires, slow-motion photography, or other techniques available in 1969 would have produced obviously artificial results that differ markedly from authentic lunar footage. Beyond the technical impossibilities lies an even more fundamental problem with conspiracy theories. Successfully orchestrating such an elaborate deception would have required the active participation and silence of approximately 400,000 people who worked on Apollo across dozens of organizations and contractors. Statistical analysis shows that secrets involving this many people leak in under 4 years on average, yet no credible whistleblowers have emerged in over 5 decades. The mathematical improbability of maintaining such massive secrecy makes the conspiracy theory logistically absurd before even considering the technical evidence. The 500,000-person conspiracy problem. The sheer number of people who would have needed to participate in such a deception reveals the fundamental impossibility of the conspiracy theory. Successfully faking the Apollo moon landings would have required the active participation and silence of approximately 400,000 people working across dozens of organizations, contractors, and international partners. This figure includes NASA employees, contractor personnel, military support staff, university researchers, international scientists, and government officials who possess direct knowledge of mission operations. The Apollo program employed workers at facilities spanning the entire United States, from the Kennedy Space Center in Florida to the Johnson Space Center in Texas, the Marshall Space Flight Center in Alabama, and countless manufacturing facilities operated by private contractors. Major aerospace corporations involved in Apollo included North American Aviation Grumman Aircraft, Boeing Douglas Aircraft, IBM, Motorola, and hundreds of smaller subcontractors who built everything from spacecraft components to ground support equipment. Each company employed thousands of engineers, technicians, and managers who understood specific aspects of lunar mission operations. North American Aviation alone assigned over 30,000 employees to Apollo work, while IBM provided computer systems that required teams of programmers and operators who processed real mission data throughout each flight. International partnerships expanded the conspiracy requirements beyond American borders. Australia provided tracking stations operated by local personnel who monitored spacecraft communications throughout lunar missions. British scientists at Jodrell Bank Observatory independently tracked Apollo flights and would have detected any discrepancies between claimed and actual spacecraft positions. Swedish researchers participated in experiments using Apollo-deployed equipment, while scientists from dozens of countries received and analyzed lunar samples returned by the missions. Mathematical analysis reveals the statistical impossibility of maintaining such widespread deception over extended time periods. Researchers have calculated that the probability of keeping a secret decreases exponentially with the number of participants involved. A conspiracy involving 400,000 people would have a 50% chance of exposure within just 2 years and virtually zero probability of remaining hidden for over 5 decades. These calculations assume that most participants want to keep secrets, but ignore the powerful incentives that would motivate revelation of fraud. Historical precedents demonstrate that much smaller government secrets invariably leak to the public despite official efforts to maintain secrecy. The Manhattan Project involved only about 130,000 people and operated for less than 4 years before information began reaching the public. The Watergate scandal exposed presidential misconduct through investigation of activities involving fewer than 50 people. More recent examples include Edward Snowden's revelations about NSA surveillance programs and Chelsea Manning's disclosure of classified military documents, both involving much smaller groups than would have been required for Apollo deception. Career incentives would have strongly motivated insiders to reveal fraud if it existed, particularly as participants advanced in their professions and gained independence from direct government employment. Engineers and scientists who worked on Apollo missions went on to leadership positions at universities, private companies, and research institutions where exposing government deception would have enhanced rather than damaged their professional reputations. Academic researchers face strong pressures to publish groundbreaking discoveries, and proving that the moon landings were faked would have represented the scientific scoop of the century. The logistics of coordinating deception across multiple agencies and countries would have required communication and control mechanisms that exceeded the organizational capabilities of any existing institution. Different agencies operated under separate command structures with competing priorities and limited coordination mechanisms. NASA reported to civilian leadership while military contractors answered to Defense Department officials. International partners maintained their own independent oversight systems that would have detected inconsistencies in American claims about mission operations. Beyond the human element, the technical requirements for creating convincing fake footage would have been impossible using 1960s technology. Even Stanley Kubrick's sophisticated 2001, A Space Odyssey still contained air movement artifacts that revealed its Earth-based production. No studio could simulate vacuum dust behavior then or now. Even Mythbusters' big studio test failed to mimic lunar dust patterns that follow perfect parabolic trajectories without air resistance. Technical documentation and procedures were made publicly available through NASA's policy of open scientific communication, creating verification opportunities that extended far beyond government control. Mission transcripts, flight plans, engineering specifications, and operational procedures were published in thousands of pages of documentation that independent researchers could examine for consistency and accuracy. University libraries worldwide maintain complete collections of Apollo technical documentation that would have revealed evidence of deception if any existed. Congressional oversight mechanisms required NASA officials to provide detailed accounting of program activities to legislators who represented competing political parties and constituencies. Budget hearings, progress reports, and technical briefings created formal records that would have revealed discrepancies between claimed and actual program activities. Politicians from both parties had incentives to investigate and expose any evidence of fraud, particularly as public. Support for space spending declined during the late 1960s and early 1970s. The technological infrastructure required to support Apollo missions created physical evidence that thousands of people could observe and verify independently. Launch facilities, spacecraft manufacturing plants, mission control centers, and tracking stations operated with equipment and procedures that corresponded to actual lunar mission requirements. Maintaining fake facilities that appeared to support real missions would have required duplicating the entire Apollo infrastructure at enormous additional cost. Quality control and safety procedures within the aerospace industry created additional verification mechanisms that would have detected deceptive activities. Engineers and technicians were trained to identify and report any discrepancies or safety violations that could compromise mission success or crew safety. These professional standards created cultural expectations that would have made coordinated deception extremely difficult to implement without detection. The scale of required secrecy makes conspiracy theories about Apollo deception logistically absurd when examined against real-world examples of how information flows within large organizations. But perhaps the most compelling evidence comes not from what happened 50 years ago, but from what continues happening today as modern space exploration builds directly upon Apollo's achievements. Modern space missions confirming Apollo evidence. Today's space missions depend on Apollo's discoveries as fundamental reference points for navigation, equipment design, and scientific research. NASA's Artemis program uses Apollo landing site coordinates and surface measurements when planning return missions to the lunar surface. Engineers designing modern spacecraft rely on environmental data collected by Apollo astronauts as baseline information for equipment that must survive lunar conditions. This practical dependence on Apollo achievements demonstrates that current space agencies treat the historical missions as established scientific fact rather than questionable claims requiring verification. International space agencies routinely use Apollo equipment locations as calibration references for their own lunar operations. The Lunar Reconnaissance Orbiter employs Apollo landing sites as known reference points when calibrating cameras and mapping instruments. Chinese Chang'e missions photograph Apollo sites specifically to validate their navigation systems, using precise coordinates of astronaut-placed equipment to verify that their spacecraft positioning systems function correctly. European and Indian lunar missions reference Apollo geological surveys when selecting targets for scientific investigations, building their research programs on foundations established during the original missions. Ongoing experiments continue using equipment that Apollo crews physically installed on the lunar surface over 50 years ago. The Lunar Laser Ranging Experiment bounces laser pulses off retroreflectors placed by astronauts measuring Earth-Moon distance with millimeter precision. These measurements, conducted regularly by observatories worldwide, have revealed that the Moon moves away from Earth at 3.8 centimeters per year through decades of continuous data collection from Apollo-placed equipment. Scientists planning future missions use this drift data to calculate precise orbital mechanics for spacecraft operations. Modern analysis has consistently validated Apollo measurements using techniques unavailable during the original missions. Advanced computer models of space radiation exposure confirm that Apollo astronauts received radiation doses within safe limits during brief trips through radiation zones and lunar surface operations. Sophisticated geological analysis using current laboratory equipment has verified that lunar samples exhibit characteristics consistent with formation in the Moon's airless, low-gravity environment over billions of years. Contemporary seismic data processing applied to Apollo-deployed instrument readings has revealed new details about lunar internal structure that match predictions made by scientists in 1970s. Private space companies invest billions of dollars in technologies that build directly upon Apollo foundations. SpaceX engineers study Apollo mission profiles when designing trajectories for Starship lunar missions, using historical flight data to validate navigation systems. Blue Origin's lunar lander development incorporates lessons learned from Apollo descent and landing procedures, treating the historical missions as proven examples of successful lunar operations. These companies stake their financial futures on technologies that assume Apollo achievements were authentic and reliable. International Space Station cooperation demonstrates the impossibility of sustaining space-related deception across multiple nations and decades. The ISS program involves space agencies from the United States, Russia, Europe, Japan, and Canada working together on complex technical projects requiring absolute precision about capabilities and procedures. Russian cosmonauts and American astronauts work side by side using life support systems, navigation equipment, and operational procedures that trace their development to technologies pioneered during Apollo missions. This level of international technical cooperation would immediately expose systematic deception about fundamental space exploration capabilities. Emerging space nations treat Apollo achievements as established historical facts when developing lunar exploration programs. China's space agency references Apollo mission data when planning Chang'e operations, using historical landing site coordinates and surface measurements as baseline information. India's space program incorporates Apollo-era understanding of lunar environmental conditions into mission planning, while private companies from multiple countries use Apollo technical specifications as starting points for spacecraft designs. These nations have no political motivation to support American historical claims if credible doubt existed about their authenticity. The entire modern space industry operates on foundations established through Apollo mission achievements, creating technological and scientific infrastructure that would collapse if those foundations were false. Orbital mechanics calculations used by every space agency worldwide incorporate understanding of gravitational fields and trajectory planning validated through Apollo missions. Spacecraft life support systems, navigation technologies, and communication protocols used throughout the international space community trace their development to innovations proven successful during lunar exploration. Current lunar mission planning assumes accuracy of Apollo surface surveys and geological assessments when selecting landing sites and scientific targets. NASA's Artemis program identifies specific landing locations based on Apollo-era mapping and resource assessments, while commercial lunar missions reference Apollo data when planning operations. This practical reliance demonstrates that mission planners consider Apollo achievements reliable sources of engineering and scientific data rather than questionable claims requiring independent verification. Advanced laboratory techniques now reveal details about lunar formation and solar system history impossible to detect using 1960s equipment. But these discoveries consistently confirm rather than contradict basic findings made through original Apollo research. Isotopic analysis using modern mass spectrometry validates age estimates made from Apollo samples, while advanced microscopy reveals formation processes that match theoretical predictions developed through lunar material studies. Despite this overwhelming evidence, conspiracy theories persist because believing exposes people to social prestige, a sense of special knowledge, plus algorithms amplify extreme ideas. Social media drives polarized echo chambers, triggering confirmation bias that defies new evidence. The cumulative effect of modern space exploration has strengthened rather than weakened evidence supporting Apollo achievements, creating an interconnected verification system spanning multiple decades, countries, and technological generations. Each new mission adds confirmation to the historical record, while ongoing research using Apollo-placed equipment provides continuous verification that the original missions accomplished exactly what they claimed. Yet, conspiracy theorists continue focusing on technical objections that seem sophisticated on the surface, particularly concerns about radiation exposure that
the Van Allen belt
would
solution
have encountered during their journey to the moon. The Van Allen radiation belts represent perhaps the most technically sophisticated argument that conspiracy theorists use to question lunar missions, suggesting that deadly radiation would have killed any astronauts attempting to travel beyond Earth's protective magnetosphere. These radiation zones, discovered by physicist James Van Allen in 1958 using data from the first American satellite Explorer 1, consist of charged particles trapped by Earth's magnetic field in two distinct regions extending from roughly 400 to 36,000 miles above the planet's surface. The inner belt contains mainly high-energy protons, while the outer belt consists primarily of electrons, both capable of causing serious harm to unprotected humans during extended exposure. NASA engineers understood the Van Allen belt challenge well before Apollo missions began and developed specific solutions to protect astronauts during their brief transit through these radiation zones. The key insight was that radiation danger depends heavily on both intensity and duration of exposure. Apollo's spacecraft passed through the most dangerous portions of the Van Allen belts in approximately 30 minutes during each direction of travel, spending far less time in high radiation areas than critics often assume. Mission planners calculated precise trajectories that skirted the edges of the Van Allen belts rather than passing directly through their centers, where radiation levels reach their highest concentrations. Apollo trajectories skirted the belts, and astronauts spent under an hour total passing through radiation, receiving only 0.46 radians, equivalent to 46 chest X-rays. The spacecraft followed paths that took advantage of gaps in the radiation fields and variations in particle density that allowed transit through regions where radiation levels were significantly lower than peak measurements. The timing of Apollo launches was carefully coordinated with solar activity cycles to avoid periods when solar storms would have intensified Van Allen belt radiation. Solar flares and coronal mass ejections can dramatically increase the number of charged particles trapped in Earth's magnetic field, potentially raising radiation levels to dangerous intensities. NASA monitored solar weather conditions continuously and would have delayed launches if significant solar events threatened to create hazardous radiation conditions during planned mission timeframes. Spacecraft shielding provided additional protection through the aluminum hull of the command module, which absorbed much of the lower energy radiation encountered during Van Allen belt transit. The command module's heat shield, designed to withstand the intense temperatures of atmospheric reentry, also served as effective radiation shielding during the portions of the trajectory where spacecraft orientation positioned this thick protective barrier between astronauts and the highest radiation sources. Apollo crews wore dosimeters that continuously measured their radiation exposure throughout each mission, providing precise documentation of actual doses received rather than theoretical calculations. These measurements showed that astronauts typically received between 0.16 and 1.14 rem of radiation during entire lunar missions, with Van Allen belt transit contributing only a small fraction of this total. The dosimeter readings were recorded in official mission reports and have been available for independent analysis by radiation protection specialists worldwide since the missions concluded. The distinction between dangerous extended exposure and relatively safe brief transit explains why Van Allen belts posed manageable risks for Apollo missions while remaining hazardous for longer duration space activities. Astronauts working on the International Space Station, which orbits within the lower Van Allen belt, receive careful monitoring and rotation schedules to limit their cumulative radiation exposure over months of orbital operations. The radiation environment that would be deadly during extended residence becomes manageable during brief passage. Comparing Apollo radiation exposure to familiar medical and transportation sources provides perspective on the actual health risks involved. A typical Apollo mission exposed astronauts to radiation levels equivalent to several chest X-rays or a few months of natural background radiation experienced by people living at high altitudes. Commercial airline pilots and flight attendants who spend careers flying at altitudes with elevated cosmic radiation typically receive annual radiation doses comparable to what Apollo astronauts experienced during their entire lunar missions. Modern space missions continue using radiation protection strategies developed during the Apollo era, demonstrating the ongoing validity of the engineering solutions that made lunar travel possible. Current spacecraft designs incorporate shielding materials, trajectory planning, and exposure monitoring techniques that trace their development directly to methods proven successful during Apollo missions. The International Space Station uses aluminum shielding and operational procedures that evolved from Apollo-era radiation protection research. Recent unmanned missions have provided additional confirmation that Apollo radiation calculations were accurate and that the protection methods used were adequate for crew safety. The Van Allen Probes mission, launched in 2012 specifically to study these radiation belts, has mapped particle distributions and energy levels that closely match the measurements and predictions used by Apollo mission planners in the 1960s. These modern measurements validate the original understanding of Van Allen belt characteristics and confirm that the transit strategies used by Apollo were based on accurate scientific data. Advanced computer modeling using current understanding of space radiation environments has confirmed that Apollo trajectories and shielding provided adequate protection for lunar missions. Modern radiation transport codes, which can simulate particle interactions with spacecraft materials and human tissue far more precisely than 1960s calculations, consistently show that Apollo protection methods were sufficient to keep crew exposures within safe ranges. Over 5 decades, moon rocks, laser reflectors, orbiter photos, Soviet tracking, and the loud silence of our greatest rival combine in an unbreakable chain of proof. These conspiracy theories persist not for lack of evidence, but because doubt can now be more profitable and fun than truth. If you want the full story, check credible science sources, and keep asking tough questions about everything, just not this one. Yet, understanding why people continue believing these theories despite overwhelming evidence requires examining something more complex than technical facts or historical documentation. Why conspiracy theories persist despite evidence? The psychology behind these persistent beliefs reveals how human nature interacts with information in ways that favor compelling narratives over complex realities. Moon landing conspiracy theories persist because they offer psychologically satisfying alternatives to accepting that humans accomplished something truly extraordinary through careful planning, advanced engineering, and tremendous effort. These theories provide believers with a sense of possessing special knowledge that ordinary people lack, transforming them from passive observers of history into active investigators who have uncovered hidden truths that escape millions of others. Conspiracy thinking offers powerful psychological rewards that evidence alone cannot easily overcome. When someone believes they have discovered a massive deception that fooled the entire world, they experience feelings of intellectual superiority and unique insight. This sensation becomes particularly appealing during periods of personal uncertainty or social upheaval, when individuals seek explanations that provide clear villains and simple answers to complex problems. The moon landing conspiracy offers both a clearly defined enemy in government agencies and a straightforward explanation that replaces the messy complexity of actual space exploration with a clean narrative of deliberate fraud. Cognitive biases work against the acceptance of corrective information, even when that information comes from authoritative sources with extensive documentation. Confirmation bias leads people to seek out information that supports their existing beliefs while avoiding or dismissing evidence that contradicts their preferred explanations. Once someone becomes convinced that moon landings were faked, they begin filtering all subsequent information through this belief system, interpreting ambiguous evidence as support for conspiracy theories while explaining away contradictory evidence as part of the ongoing deception. The backfire effect makes direct contradiction of conspiracy beliefs counterproductive in many cases. When presented with evidence that challenges their conspiracy theories, believers often respond by strengthening their original beliefs rather than reconsidering them. This psychological defense mechanism protects existing worldviews from information that would require significant mental effort to process and integrate. The more evidence that accumulates supporting moon landings, the more elaborate and comprehensive the required conspiracy becomes, leading believers to conclude that the deception must be even more sophisticated than they originally imagined. Social identity plays a crucial role in maintaining conspiracy beliefs regardless of available evidence. People who identify as conspiracy theorists often belong to communities that provide social support, shared purpose, and group belonging that they might not find elsewhere. Abandoning conspiracy beliefs means risking rejection from these communities and admitting that fundamental aspects of their worldview were incorrect. The social costs of changing beliefs can outweigh the benefits of accepting accurate information, particularly when conspiracy communities offer friendship, validation, and a sense of shared mission. Distrust in institutions and expertise creates fertile ground for alternative explanations to take root and flourish. Decades of documented government deception in areas ranging from foreign policy to domestic surveillance have created reasonable skepticism about official accounts of controversial events. This institutional distrust extends to scientific and academic communities that support mainstream explanations of historical events. When people lose faith in traditional sources of authority, they become more receptive to alternative explanations regardless of the evidence supporting those alternatives. The complexity of space technology makes it relatively easy to sow doubt among people without technical expertise in relevant fields. Most individuals lack the background knowledge necessary to evaluate claims about rocket engineering, orbital mechanics, or radiation exposure in space. This knowledge gap creates opportunities for conspiracy promoters to present technical-sounding arguments that seem credible to non-experts but contain fundamental errors that trained specialists can easily identify. The asymmetry between the effort required to make false technical claims and the expertise needed to refute them favors conspiracy promotion over factual correction. Modern media environments amplify these psychological tendencies through algorithms that prioritize engagement over accuracy. Social media platforms and video sharing sites boost content that generates strong emotional responses, typically anger, outrage, or excitement. Conspiracy theories reliably produce these reactions, while factual content about space exploration may seem boring by comparison. The business model of digital platforms creates financial incentives to promote conspiracy content regardless of its accuracy, since controversial material drives higher engagement rates and advertising revenue. The entertainment value of conspiracy stories provides additional appeal that mundane reality cannot match. Tales of elaborate government deception, international cover-ups, and hidden truths offer narrative excitement that straightforward accounts of engineering achievements lack. Conspiracy theories transform believers into protagonists in ongoing detective stories where they can uncover clues, solve puzzles, and reveal secrets. This entertainment aspect makes conspiracy theories more engaging and memorable than factual explanations that require understanding complex technical details without offering comparable narrative satisfaction. Educational systems have not adequately prepared people to evaluate the credibility of information sources or recognize sophisticated propaganda techniques. Traditional media literacy education focused on identifying bias in newspapers and television broadcasts, but did not address the challenges of evaluating user-generated content, algorithmic curation, or coordinated disinformation campaigns. Many people lack the critical thinking skills necessary to distinguish between legitimate skepticism and unfounded conspiracy theories, particularly when those theories are presented using professional production techniques and authoritative-sounding narration. Understanding these psychological and social factors provides essential insights for addressing conspiracy theories effectively. Simply presenting additional evidence rarely changes deeply held beliefs that serve important psychological and social functions for believers. More effective approaches involve addressing the underlying needs that conspiracy theories fulfill, building trust in reliable information sources, and creating alternative communities that provide social support without requiring acceptance of false beliefs. These human factors explain why conspiracy theories persist despite mountains of documentation, but they cannot change the fundamental reality of what actually happened 50 years ago. When we examine the complete picture, the evidence forms an unbreakable chain across multiple disciplines and decades of verification. Physical samples analyzed by scientists worldwide, equipment still functioning on the lunar surface, photographs from competing nations, and the silence of America's greatest rival during the height of the Cold War all point to the same conclusion. The Apollo missions represent genuine human achievement, documented more thoroughly than virtually any other historical event. The conspiracy theories persist not because evidence is lacking, but because human psychology makes us susceptible to narratives that offer simple explanations for complex realities. Apply this same critical examination to other areas where misinformation spreads.